Hello everyone. Today I'll be walking you through this Python notebook to predict the loan status as the binary outcome variable. And also I'll be covering the steps I took to improve my classifier performance and how I assessed and some potential improvements that I can make if I have more time and resources. The first two steps are quite straightforward, just importing the required packages, reading the training and testing data. And by using the info function, we can have a holistic view of the two data sets. And then we define the numerical features versus the categorical features. And we check if there are missing values. And unfortunately, there's none. And then we perform our first engineering technique, just removing the outliers, since outliers often significantly impact the performance of the model we construct by skewing the results and cause bias the predictions. And Turkey rule is the option we choose. That is setting the lower limit as the first quartile minus 1.5 times the interquartile, and the upper limit as the third quartile plus the 1.5 times the interquartile. And after that, we did some exploratory data analysis by constructing a correlation matrix between those variables. And we did mapping, just converting those string inputs into numbers. Another technique we perform is one-hot encoding on the age group so that the model can learn that specific relationship between the X variable and the target variable more accurately. And then we define several new features, and scaling is applied to numerical variables so that it ensures that all features are roughly on a similar scale and preventing the bias. And we run the value count function to see the proportions of the outcome variable, the loan status. And we found that they are quite imbalanced. In this way, we need to oversample the smaller group, which is another technique we perform. And our to-go is smooth. And since we have removed the outliers in the previous step, the mode can not only perform well, but also save our time. And now from the histogram, we can see that the two groups are roughly at the same size. And sometimes just the mode can produce duplicative values, and we need to remove them. And fortunately, in this case, we still have none of them. And we apply the pi caret, and using the F1 score as the metric, we select the model. And the best model is the X-ray boost. And by constructing the X-ray boost, we found that the model F1 score is 0.9477, and the confusion matrix is constructed here. And the values on the top left to the bottom right corners are the correct predictions. And we also draw a ROC curve to see that the area is 0.991, which is very high. And we also draw a learning curve, and it indicates a little bit of overfitting. And the method we need to perform them is to just use the k-fold so that to guarantee that they're trained on the different sets so that they guarantee a consistent input. And also, I just want to talk about the false positive and the false negative. And in a loan approval settings, the false positive occurs when the model incorrectly classifies a high-risk borrower as credit-worthy and approves their loan. And a false negative happens when the model incorrectly classifies a low-risk borrower as high-risk, denying them a loan that they could have repaid. And in the first scenario, we just may just lost. In both those scenarios, we may just lost our some profits. And let me have a discussion on the three different machine learning models. The first one is the logistic regression. It can give out a good F1 score on balanced data set, but it does not have a good performance on the imbalanced one, especially those with nonlinear data. And this is often used to predict the churn rate of a certain business. And the second one is random forest. It can balance the precision and recall better than the logistic regression using class weighting so that it have a high F1 score on the structured data and the high dimensional data. However, it takes much longer time to complete the process, and it is often used to assess the loan risks. The last one is the deep neural networks with a high F1 score on large data sets, while it cannot be used to deal with relatively smaller ones. It is often used in fraud detection in banking. And lastly, if I have more time and resources, I will enhance the model with external data sets such as macroeconomic trends and real-time financial indicators. Those could significantly improve the predictive accuracy and adaptability to economic changes. And for monitoring and the model performance and handling the data drift, we can schedule a regular monitoring process, performance metrics like precision, recall, and AUC and ROC. And that's so much for today's presentation. And thanks for your close attention.